So in the last video we have covered inner join. So we have covered the inner join topic. That is, we have covered theta join and natural join. Okay. So in binary relational operations we have two in joins and division. So in joins we have inner join and outer join. So in inner join we have theta join and natural join. We have covered these two things in the last video. That is, we have completed inner join. Now we'll complete outer join. In outer join we have left outer join, right outer join and full outer join. Okay. So coming to the outer join, that is this outer join, we'll first cover this left outer join. Okay. In outer join we'll cover first left outer join. In left outer join, see, left outer join is denoted like this. This is the S table, this is the D table. We'll take these two tables, S and D, and we'll perform a left outer join operation on these two tables. Okay. So let us take student ID as 101 to 105 and student names are Raju, Ravi, Ramu, Hari, Suresh. We have taken this. Let us take these things, and suppose department ID is suppose let us take example 12135. Some 121012105 Raju, some random names Raju, Ravi, Ramu, Hari, Suresh, and some random numbers 12135. Okay. And second table is this department ID will be same in both the tables. I mean to say, like, we should use one interlinking attribute in both the tables. Any attribute should be common. Any one attribute should be common in both the tables. So this attribute is common in both the tables. And the department name is for department ID 1 it is CSC, for department ID 2 it is EC, for 3 it is EEE, for 4 it is mechanical. Okay, so these two tables will on these two tables will perform outer join operation, left outer join operation. After performing we'll get this. How we'll get this? See, after performing left outer join operation on these two tables, see, we'll get the resultant this. See, you write as it is. For semester exams it will be very easy if you take these two tables as an example. You remember these two tables. Okay, you remember these two tables and write these two tables and solve this one. So if you solve this example, it will be, you will get more marks. Okay, instead of writing only theory, if you write this you'll get full marks. And if you just write this, okay, if you don't solve this table, because left outer join, right outer join means you should definitely write this example. Without writing the example, if you write only theory, you will not get marks mostly. So it is better to write. And so left outer join, see, you write this table as it is here. See, 101 to 105 Raju, Ravi, Ramu, Hari, Suresh, Raju, Ravi, Ramu, Hari, Suresh, 12135, 12135. So we have written this table here as it is, except the department name. So this department name we'll find by using the department ID, which is the common attribute in both the tables. Understand? This department name, so first we'll write this table as it is here, and after writing this table as it is here, we'll find the department name by using the department ID in common in both the attributes. So see, common attribute in both the tables. So for department ID 1, see, we have got department ID 1. For department ID 1, what is the department name? See, check here, CSC. Okay. For department ID 2, next one, what is the For department ID 2, what is the department name? For 2 it is EC. Okay, we have written EC. For department ID 1, what is the department name? For department ID 1, it is CSE. So we'll write CSE here. And for department ID 3, what is the department name? For 3 it is triple E. Okay, for 3 it is triple E. So we'll write triple E here. For department ID 5, what is the department name? For department ID 5, we don't have department ID 5, so we'll write null. Okay, so in this way we'll get the left outer chain operation. Okay, so and this is the explanation. We have to write this line. Resultant relation will have all rows from the relation S and the matching rows from relation D. Okay, resultant relation will have all rows from table S and the matching rows from table D. Okay, and now left outer chain is completed. Right outer and full outer, we'll look into that now. So coming to right outer chain, see, a right outer chain is denoted like this, and the resultant relation will have all the tuples of D and the common tuples of S. This is the explanation. Now you will get this, you will understand this line by if you after seeing the example. So what you will do is we will take the same tables. See, we'll take the same tables as it is. These two tables, if you remember these two tables, it will be useful in left outer chain, right outer chain, and full outer chain. So we use those two tables only in all the in all of these three, left outer, right outer, and full outer. All of these three we used. So you remember these two tables as it is. So by performing right outer chain operation on these two tables, we'll get the resultant. How means you have to write like this. How means first write this table as it is here. Forget about the last line. First write these 4 rows as it is here. You can write to department ID and after that department name, or otherwise for your convenience I have written first department name and after that I have written department ID. You can also write as this, but I have written reverse. First I have written department name here, then I have written department ID here. Okay, so after writing these 4 rows here, see 1 2 3 4, 1 2 3 4, reverse I have written. So by writing these 4 rows here, we will find the student name and student ID corresponding to the department ID. So this department ID attribute is common in both the tables. Okay, this department ID attribute is common in both the tables. So we after writing this table as it is here, forget about this line after last line. So after writing this table as it is here, we'll find student name and student ID. These two attributes will find from this table corresponding to this attribute, corresponding to this department ID. Okay, for department ID 1, what is the student name and student ID? For department ID 1, student name is Raju and student ID is 101. Okay, for department ID 2, student name is Ravi, student ID is 102. For department ID 3 here, for department ID 3, student name is Hari, student ID is 104. Student name is Hari, student is 104. For department ID 4, so we don't have 4 here. For department ID 4, what is the student name and student ID? For department ID 4, we don't have any student name and student ID, so we'll write null. So these 4 lines we have completed. Okay, so I've said forget about this line. Okay, so these 4 lines we have completed. For 4 we don't have any value, any student name and student ID, so we will write null. Okay, these 4 lines are completed. Now see here, we don't have 4, so we written null, but here we have 1 repeated 2 times. See, for 1 we have written Raju, for 2 we have written Ravi and 102. For 3 we have written, see, 2 repeated 2 times, but we have not used this Ramu and 103. We have directly got 3 and we have used this Hari and 104. 4 we don't have anything, we have written null, but 1 here we have got 2 times, so we'll write 1 here. and for 1 corresponding values are Ramu and 103, and for 1 corresponding department name is CSE. So we'll write here. This is how we'll get right outer join. Now we'll look into full outer join. Okay, so coming to the full outer join, how we'll write is, we will use these same tables and we'll perform full outer join operations on these two tables. See, student ID 101 to 105. Okay, Raju, Ravi, Ramu, Hari, Suresh 12135. Forget here also, forget about the last line, and first you write as it is 101 to 105, Raju, Ravi, Ramu, Hari, Suresh 12135. Okay, so after writing this table here as it is, you have to find department name. You have to find department name corresponding to the department ID. So for department ID 1, what is the department name? For department ID 1, department name is CSE, we have to write here. And for department ID 2, department name is EC, we have to write here. For department ID 1 again came here. For one department ID 1, it is CSE, so we have to write CSE here. For department ID 3, 3 is triple E, so we have to write triple E here. For department ID 5, what is the department name? 5 we don't have, so we'll write null. Okay, these lines are completed. I said forget about the last line. Now we'll see how we have got the last line. See, 12135, we have written this table as it is. We have written this table as it is here. So after writing this table as it is here, we have taken these values from this table. For 1 we have CSC, 2 we have this 3, so we have taken like this. So last line we have got null, 4, mechanical. How we will get is, so the full outer join means full outer join means resultant relation will have all the rows from both the tables S and D. All the rows from both the tables. So this we have to remember. Here it is different. Resultant relation will have all the tuples of D and common tuples of S. We'll only get all the tuples of D. From D only we have to take all the tuples, and common tuples from S we have to take. But here it is not like this. In full outer join it is not like this. In full outer join we have to take all the rows, all the tuples from both the tables. Tuples means rows. Rows means tuples. Here we have written tuples. Here it is rows. We can also write tuples here. And DBMS will say rows as a tuples. Okay. So resultant relation will have all the rows from both the tables S and D. From both the tables we have to cover all the rows. But see here, we have covered 12135. 12135 we have covered, but 4 is missing here. So we'll take 4 here and 4 mechanical. Okay. And but 4 we don't have any value, we write null. So that is how we get full outer join. Thank you. If you like this video, like my video and subscribe to my channel. And in the next video we'll cover the topic. See, joins are completed. Left outer, right outer, full outer also completed. So inner join, outer join both are completed. The previous video I have covered this, and in this video I have covered this. So joins are completed. Now in the next video I will cover divisions. Thank you.